So can folks hear me at home? Good, thank you. Appreciate it. Campus correct. Oh, really? Oh, you're right. Oh, push. Okay, so we should go ahead and start. The hello, momentary pause and oh no, there we go. Computer is being slow, but we got there eventually. So the main thing today, well, there are two things, and we'll see how long the first one takes as to sort of where that puts us on the second one. But the collage factory is due tonight, and so the first thing is like, what questions people have, because I would be happy to spend much or all of today answering questions about collage factory stuff if folks have them. Otherwise, we'll start it on sounds and chapter 7. So, questions about collage factory? Nick.
I was a little bit confused about the requirement that said for including one part of an image in its regular size and one copy of that part of the image resized. So first question was, when you say including one part of an image in its regular size, does that mean the whole image? Or
no, it could be a part of the image, but the part of the image at the size that, oh, so here, might be easier if I draw on the board, and you can tell me if this helps or not. So let's imagine this is your, oh, got to turn on the projector. Momentary pause. Totally forgot to do that. So everybody at home can see, but nobody in the classroom can. Try again. Ooh. Down. Okay, so let's imagine this is the original image. And let's imagine that it's, I don't know, let's say it's 1,000 by 1,000. Just for a nice big even number, okay? Now what this is saying is that you can use a part of the image. So let's imagine that we take a 200 by 200 chunk out of the middle. that make sense? And then here's our canvas. Whoa, which looks a lot like Missouri, but we're going to not worry about that. And the canvas is supposed to be 800 by 800. The fact that it's taller than 1,000 over here, we're not going to worry about that because this is not art. And so that requirement says you're going to have to, like, if you want to do that thing, you would copy this in its original size somewhere. I don't know, let's say we put it in the top left, top right corner. So this is 200 by 200. Okay. And that the other copy needs to be a different size. So it'll still start 200 by 200. It will become a different size, not because we clipped a different piece out, but because we made it bigger or smaller as we copied it. Okay. So maybe we take this chunk, come here, and there we go. Let's say we copy this down to the bottom left and we make it 400 by 400. Wow. Like that. And there are algorithms in the book. Oh, there's my book. There are algorithms in the book. Resizing index. Don't remember which chapter. Oh, come on. Oh, scale. Scaling 176. Yeah, so there's in section 6.3.7, there is program 82 scales something to be smaller, and program 83 scales something to be bigger. And these are both interesting because when you make something smaller, you're essentially throwing away some information. You have to make a decision about what to lose because there's less information in the smaller version than there was in the bigger version. One way to think about this is just how many numbers are there, right? And there's 3 numbers per pixel. The bigger version's got more pixels, so it has more numbers. There's more data there. The smaller version has fewer pixels, so it's just gonna have fewer numbers, okay? So you're losing information when you make it smaller. And there are different decisions you can make about how to do that, right? You could, let's say you're trying to make it half as big. That means, oh, no, we'll go with that. That you're going to turn a group of 4 pixels into a single pixel if you're trying to cut it in half by both dimensions. And so you could just map this pixel. An easy solution would be to map this pixel across and just throw away the other 3. A slightly more sophisticated one would be to take the average of these 4 pixels and use that as the values of red, green, and blue for the new pixel, right? You could also get fancier about it and expand the area that you average together. That's probably going to increase the likelihood of it blurring somewhat, but it also reduces some other effects. So kind of depends on what you like as a visual effect. But you're throwing some information away going that direction. If you go the other direction, you're trying to go from 1 pixel to 4, say, let's again imagine we're doubling the size of the image in both directions, then you don't have a lot of choice other than to just map this to all 4 of those pixels. Again, you could try to do some fancier things and take averaging of neighbors, because one of the things that's going to happen when you blow it up is you're going to, especially if you blow it up a lot, you'll start to see squares that are the pixels become large, right? And we've seen that actually when we in the Picture Explorer, when we've blown up things big enough that we can see the pixels and they come out as like squares. And that's going to happen here. If you blow something up a ton, you're going to see square pixels. And that's just unavoidable because you're trying to take a picture that doesn't have as much information as you want and make it larger. So this business that you see on TV, on crime shows, where they take some grainy CCTV image and the tech expert somehow blows it up so that you can read the monogram on some guy's shirt reflected in the mirror of a car nearby, that's just nonsense. There's just not enough information in the picture to do that. You can certainly, if you know what you're doing and you've got the right tools, you can enhance a picture a lot and you can get information out of a picture that might not have been immediately visible. That absolutely happened. But there are things that happen in movies and television that are just way past reality. So, be prepared.
Right, so when it makes a picture like that, are we just adding empty space?
Well, if you added empty space, so like if you only put color here and you left these 3 blank, it would look weird because there'd be a lot of white, right? So what you actually do is you copy this color into all 4 spots. So you take what was 1 pixel and make it 4 pixels in the new image. So it becomes a bigger kind of super pixel. And you do that for every pixel. So if let's see, if I do, let's do green. If the pixel below this, say, is this green color, then I'm going to make a block of 4 pixels that are that green color. And that's going to end up giving me a new picture that's twice as big as the original picture that I had. It'll be twice as wide and twice as tall, but all the pixels will be larger. So, or the actual pixels will be the same size, but the effective pixels, what we see as pixels, these squares of color, will now be bigger. And if we, instead of doubling it, say we quadrupled it or multiplied it by 8 or 10, then those new blocks of color would start to become big enough that they would be clearly visible to the eye as blocks, and you kind of lose the effect. All of this digital image stuff depends on the idea that if pixels are small enough, your brain doesn't perceive them as separate dots of color, but it perceives them as a continuous image. And if you make the sort of super pixels, if you want to think of it that way, too big, it breaks that illusion. And we start to see them as blocks of color and not as sort of a smooth range of colors. Does that answer the right question and that make sense? Okay. And did that answer your question in a reasonable way? Okay. No, that's fine. So, but before we go to Nick's second question, does anybody else online at home have a question about what we've just done with the business about resizing pictures, any of that stuff? Anybody here in the room have a question about that? Joseph.
I was thinking about it. So you take an image and you shrink it down to get it down. The smaller image
Right.
So let's say you have an image.
Right. So how would you do that? So Joseph's question is, what if I think in part the question is, what if the dimensions don't match? So if you start with an 800 by 600 and you want to turn it into a 200 by 200 or 300? Okay. So let's say a 200 by 200, how would you do that? So let's actually think about that for a second, because I think that's an interesting question. So Joseph's idea is that we're going to start with an 800 by 600. And we want to scale this. So you don't want to crop anything. You don't want to lose anything. You want to just move the whole thing into a 200 by 200. And let's just, to make it a little clearer what's going on. Tree, and over here we'll have a person. So when we scale this, if we're not going to do any cropping, we're going to end up squishing it more left to right than top to bottom, because 800 was wider than 600, and now they're going to be the same, 200 by 200. So we're going to distort the image a little bit, right? The tree will now look taller and skinnier, and the person's now going to look taller and skinnier proportionally, and they're going to be proportionally closer together. So how would we do that? Well, this tells us we're going to have to map source pixels onto target pixels using different math for the x coordinate than the y coordinate, because the x coordinate is going to be going from 800 to 200, and the y coordinate is going to go from 600 to 200. And so the math for those two things are not going to be the same. And in particular, if we're going to have x, s, y, s for source, and we're going to map to x, t, y, t for target, what's the math going to look like? Well, 800 to 200, we're going to go from 0 to 0. 800 is going to go to 200. How do we get from 800 to 200? What's the piece of math that gets us there? Divide by 4, correct. So xt is going to be 800, is going to be xs times 200 divided by 800, which is xs over 4. So we're going to have to divide by 4 in the x-axis. The y-axis is, is 200 divided by 600. So that's ys divided by 3. So we'll end up dividing the x and y coordinates by different amounts. We'll multiply them by different factors to get from one to the other. And that would also be true if we were going from small to big. We would multiply by possibly different factors if the aspect ratio of the target was different than the aspect ratio of the source. Does that answer the right question? Cool. Other questions about the scaling stuff? And if people want, we should probably go through other questions, but when we finish questions, if it would be useful, we could do a simple example of a scaling program just to see that happen here on the computer. And several people here nodded, so I'm going to take that as that might be a useful thing to do. But let's actually have a chance to go through other questions first, in case there are other questions people want to ask. And Nick, I know, has another question. So what's Nick's other question?
So I just confirm, a certain part of the collage can meet multiple of the criteria.
Absolutely.
So, for example, I could have things be clusterized, and that would also count as one of the 5 filters.
Yes.
It could also be on one of the repeats.
Could, yes, absolutely. Yes.
Okay.
Yeah. So, like, to take this as a simple example, since I already have it drawn, if you So moving this to here and here would satisfy the copying in two places with different sizes. If you also say posterize this copy, like this copy was left alone and this was posterized or sepia or something, that would count as one of those other image modification things. So you would get the resizing and the I modified the image. And if you sepiaed and flipped it, right, you get three things for one picture because you get I moved it with a different size, I sepiaed it, so that's an image manipulation, and I flipped it or rotated it, and that's whatever that category is. So yeah, you can totally do multiple things, and that's part of why we ask you to mark in comments where you think you're doing things, because there's a lot going on when this is done, and it makes it kind of tricky to grade, and trying to guess what Nick meant for this thing to be, not to pick on Nick, right? This would be true for everybody, is not trivial. And so if everyone labels, I think this is a image manipulation, I think this is a rotation, and I think this is a resizing, right? Then we can check, yes, it does seem to have all three of those properties. And then we can just go through the comments and fairly easily say, are there five image manipulations? Yes, points. Is there a rotation? Yes, points. Is there a resizing? Yes, points, right? And so the first step can be checking that all the comments are true, like that you're not just putting comments floating around in your code hoping nobody will notice, because that's not good. And then once we've checked that, then it's easy to go back through and do points in the grading system. So yeah, that's the idea there.
So I actually have like a bunch of individual functions in my collage factory. It's just like me putting all those in the name.
Yeah.
Do you want the comments to be above or for each individual function, or do you want the comments to be like for the whole factory?
That is a really good question. So if you didn't hear that, I want to make sure I repeat that one. So Nick has written a bunch of functions, and so let's say posterize, because you mentioned that. So Nick's got a posterize function. And should he put this image manipulation comment with the function, or where he calls it in his montage function at the bottom of his file? I would put it where you call it. I mean, I think this is not entirely obvious, but I think I would put it where you would call it for two reasons. One is, I think that all those things are in one place, which makes it a little easier for us to look at. The other is, you could possibly call posterize more than once. Or you might have a function that takes a parameter that lets you do different things depending on that parameter. And you might call that more than once in a way that would be useful and could possibly count as multiple things. And so if you put the comment on the function, it's less clear how it's being used in the main montage function. Whereas I think if we see the comments in the montage function, it'll be a little easier for us to chase the stuff down. So that's what I would vote for, is putting it in the montage function itself. However, right, each of you will find your own way, and I'm not like hung up on that. If you get into it and you're like, oh, I just don't think it makes sense to do that, then don't do it, right? You can do it in both places too, right? You could say, in the comment over posterize, you could say this will be used to provide image manipulation 2. And then down in the main thing where you call posterize, you could say this provides image manipulation 2, or just hashtag image manipulation 2, right? And so I think, you could always, it never hurts to be to over document what you're doing. So, well, that's really actually not entirely true. You can probably over document what you've done, but if you turn something in that's 4 times as much documentation as code, you probably lost the plot. But we'll assume nobody does that. Okay, did that answer that question? Other questions from here or from the online community of awesomeness?
I have a question.
Yeah.
So for the picture 5, like the picture 5 is actually wider than the canvas.
Correct.
And so when type test, like for example, the test 1, like it shows that my picture 5 got some problem because the x is less than 0 or bigger than the y's.
Yes. So because the last picture, picture 5, is guaranteed to be too big to fit. And several of the others can be too big to fit. So 3 and 4 are both at least 200 by 200, but could be 1,000,000 by 1,000,000. They won't be that big because that would take too long to process, but they can be much bigger than your canvas. So you have to be careful on all of the ones that could be big to use only part of them or scale them in some way. So you could solve the problem by scaling them like we've done, or taking a piece out of them like we've done here in the drawing, right? So this image, this could be pick 5. It's 1,000 by 1,000. It satisfies the criteria for picture 5 in that it is at least 200 tall and it's at least 801 wide. So how would you use something like this? Well, you could just take a piece out of it, okay? And just use that piece. Or you could take a piece and resize it. Right? You could take the whole thing and shrink it down to 200 by 200, and then place that somewhere in the target image. But you're going to have to do something like that for all of 3, 4, and 5 because they all have the potential to be too big. So you'll have to identify a part of the picture, not knowing how big the picture is going to be, right? Which is complicated. You're going to have to decide on a part of it that you're going to copy across. So probably the easiest thing to do would be to take a chunk out of like the top left-hand corner, because you know there'll be a top left-hand corner, and it's easy to pull a piece out of that. You know, a piece out of one of the other corners is also pretty easy. You could take a piece out of the middle, right? You got to work out the math there, but again, that's not impossibly difficult. You just got to do it. You could scale it to make it smaller and make it fit. And you can handle pick 3, pick 4, and pick 5 differently. So you could scale one of them. You could take the top left-hand corner of another one. You could take a chunk out of the middle of the third one, right? So all of those kinds of things are possibilities. But you will have to do something like that. Does that make sense, Yubo?
Oh.
Really? Follow up with
also question. Like so for the big picture we need to like scale it to smaller first and then put it.
You could scale it using the jest function in the book,
or just take part of the picture, right?
Or just take part of the picture, yeah.
Or like using the range.
Yes. Correct.
Okay. Okay.
Does that make sense?
Oh yeah, I got it. Okay.
Question. Other question. Anybody else? Joseph, go for it. No. Different inputs will give you different collages. That's part of the point, is that if we give you one set of 5 pictures, you're going to get one collage. And if we give you a different set of 5 pictures, you'll get a different collage. It'll have the same sort of shape and layout probably, right? If you're, let's say you're, let me make another, let's say that your final collage has some sort of setup. I don't know, let's say you've got the 100 by 100 in all four corners. You've got some sort of bottom area. You have divided this into, I don't know, 4 pieces, and you put things in those 4 pieces. I'm just making stuff up, right? That if I give you one set of pictures, it'll have this shape, but you might have like a tree here. And because we're copying this 4 places, the tree will be in all 4 places. But maybe with different color schemes or rotations or something. And maybe there's a person here and a person over here who's upside down because you did some sort of rotation. And so you might get that with one set of pictures, and then a different set of pictures, maybe instead of trees here, you get horses or a mountain landscape or a goose or whatever, right? And that maybe this is a mountain landscape now, and this is the same mountain landscape upside down. And so the picture you get will be different depending on the input images, but the structure of it, the way it's organized, and the fact that this corner is grayscale, that'll probably be the same.
Right. So the images
Yes.
but the proportion.
Well, I mean, they don't have to be. It's just it's a little tricky. Like, well, I mean, okay, let me back up. They don't have to be. That's the important part. So if you decide to scale, let's say you take let's say this bottom piece is the picture that's at least 200 by at least 801, pick 5. And you decide to scale it so that it fits in 800 wide. If it's almost exactly 200 by 800, it'll be about the same after you scale it. If, on the other hand, it's 1,000 by 1,000 and you scale it to fit, then it's going to be square. And so it'll end up taking up maybe the whole thing, right? And cover the entire picture. So if you get into scaling, some weird things can happen, and things might not have the same layout all the time. But other than that, that's the one thing I can think of. Oh, I guess if you rotated a non-square picture, its shape after rotation is going to vary depending on the input picture. So if you rotated something and it was square, then it'll fit in the same box. If you rotate it and it's a rectangle that's a non-square rectangle, then it's going to become a non-square rectangle that's taller than wide. And that could change how it lays out. So there could be legitimate reasons that the layout won't be the same. And that would be fine. And I should point out, just in case it's not clear, we're not expecting all of the outputs to be interesting or good, right? It's entirely possible. So it's a bit like my making the clouds in the dog stool picture purpley pink. Like, I very carefully tuned it for those clouds, and when we applied it to other things, it didn't work very well, right? You might have something that makes a really neat collage with these 5 images that you have, and when we put some other 5 images in, it's going to look kind of stupid, because maybe you knew where somebody's face was, and you carefully cropped the face and repeated it in the 4 corners. Again, just making examples. And that worked for your thing because you knew there was a face in exactly this location in the picture. And then we put in a picture that's just a landscape. And now that square, instead of being a person's face, is like just some random grass and a little bit of sky. And it might look much less interesting. And that's okay, because we're not asking you to make somehow a collage factory where every image it creates is amazing. I don't think that's possible, right? We're asking you to build a collage factory that can make a collage, and then, you know, in real life, what you would do, like say you were an artist and you were using this to help you build things, you might try a whole bunch of different inputs and look for ones that make interesting things, some of which might be surprising, but they still might be interesting, right? So that was a long answer to your question, but does that answer your question? Okay. Nick has a question. Oh, and then Zeke has a question.
Is it okay if with certain sets of images there is some white space?
Yeah, I think that's fine. I think that that's probably unavoidable in some ways. If you're, again, like if you were scaling an image and you don't know in advance its dimensions, we could give you kind of an extreme case where it'd be pretty hard for you to not end up with white space, and that's okay. I think that like it probably makes sense if in the test 1 and test 2 that there's probably not any white space. No, I'm not saying that's a requirement. It's certainly not in the rubric, but it'd probably be good since those are kind of normalish things. But yeah, if there's some white space, that can just be part of the image, right? And that's fine. So Zeke. Yeah. So Zeke is asking if you're going to crop a piece out like we did here, and you're going to manipulate it. So you got this piece here, and let's say you're going to sepia it over here. How might you do that? And I think there's a lot of right answers to that question, and I think both of the things you suggested are entirely reasonable right answers. So the two things that Zeke suggested, one was copy the pixels in and then sepia them in the canvas. Another was to make a new little picture and then sepia the new picture and then copy that onto the canvas. You could actually do them at the same time. You could combine sepia and copy into one action and modify the pixels as you go. All of those I think are plausible. The one that's probably least likely to get you in trouble in some ways is to make a copy, modify the copy, and then put the copy where you want it. And that's actually probably the safest option. Anything else, there's the potential that you modify some pixels that you didn't mean to modify, and then you can't unmodify them. And so doing something where you copy, this to here, then sepia that, and then copy that down into there, that's probably your safest option. But any of the, if it works, right? And any of the other things that you suggested or that I suggested are entirely feasible. And I've seen all of that happen in different ways by different people. So, but I think making a new image is probably your safest bet. Sure. Oh, I think you can totally. So Zeke's question is, should your manipulation functions copy onto the canvas, or could you have a separate copy function? I actually think having a separate copy function is a great idea. So if you have a single general purpose copy this thing onto here in this place function, and then you just reuse that over and over again, that's a lot simpler and less error prone than basically repeating that logic of copying all across the world, which is what the other option would end up being. So yeah, I think having copy on to or some equivalent would be a very good idea. Okay. Questions? Lots of good questions today. Thank you. Any questions from the home crew? Going. So we've got about 25 minutes left. Do we want to do a scaling thing to see an example of that? Several nods in this room. So the people here are winning unless the people at home want to sort of dive in and say, no, don't do it. No, nobody said that. Okay. And we got a thumbs up from somebody at home. So that's awesome. Okay, so I'm going to stop sharing this. And I'll get a couple thumbs up. So we're totally rocking. And then we're going to head over to Jess. So I'm going to share Jess. Jess. Oh, I did not share Jess. Did I share Jess? No. I shared the wrong thing. Stop share. Share Jess. There we go. That's better. Okie dokie. So, what if we take, we'll do a simple thing where we're going to take two pictures. So I'm going to call it background and inset. Oh, good. And my idea is that we'll take inset and scale it to be just 200 by 200, regardless of its initial size, and place it in the upper left of background, shifted down and left 100 in each direction. So I'm going to be taking inset, which could be a big picture. I'm going to scale it to be just 200 by 200. And then instead of setting it right in the top left-hand corner, I'm going to set it down 100 and over 100 from the top left-hand corner. So it'll be up in that part of the picture, but it won't be right in the top left-hand corner. That makes sense as a plan, peeps? Okay. So let's actually, I'll write a function that takes a picture and target dimension, which I'll call scale to. And then I will copy onto background scaled instead 100, 100. Okay. And then I will return background. So that's basically my plan. Does that make sense as a plan? And I would encourage folks, when you're working on your montage, to sort of start big and then work your way through the pieces. But do it incrementally so you can test things. So let's write def scale to. We'll have a picture, target width, and target height. And so we're going to have to, canvas will be new, make empty picture, target width, target height. So I'm going to need to make an empty picture that's the right size. Okay. And then I need to scale my picture to have that size and copy the pixels over. So I'm going to have to, for pixel in get pixels pick, X is, what we call it, X source is get X pixel, Y source is get Y pixel. And then we'll use that same math that I had a little earlier. So X target is going to be X source times the width of the original picture. Oh, I should actually have gotten that probably up here. So source width, get width, pick, source height, get height, pick. And actually, why don't I compute my scaling factors up here so I don't have to recompute them? So width scale is going to be source width divided by, oh no, the other way around. Target width divided by source width. And height scale is target height divided by source height. So this is just basically like reworking out the math that we had on the slides earlier. And I'm going through this kind of fast, so stop me if I'm going too fast. Or if it would be useful to go back to the whiteboard to look at the math, we can totally do that. Questions? Okay. So then we'll multiply by the width scale and the height scale. And that tells us where it's going to go. And then we need to get the color from the pixel. And we need to set, oh, we need to get the target pixel. X target, Y target. And then we need to set the color of the target pixel to be the color. And then we need to return canvas. Oh, and actually get pixel takes a picture and an X and Y. I would have eventually figured that out, but that was wrong. Today is the 5th. Boom. Questions about scale 2 before we try it out? Try it out. So, so I want, let's say, we'll do the gate, make picture, pick, file, and Japanese gate. And now we'll say small gate is scale to gate 200 by 200. Let's see if it works. Let's see if it works. Let's see if it works. Show small gate. So it didn't blow up. That's a win. It's a little thing. And that doesn't look good at all. Let me show you what we got. Actually, let me share the whole screen because we're going to keep doing this. So we got a completely white picture, which is not good. That is not the desired outcome. So why did we get a completely white picture? So the answer to this is not at all obvious and is likely to be very confusing. And it has to do with a weird thing about how Python and a lot of other programming languages do division. If I say, let's say 13 divided by 4, it says 3. I might have expected 3 point blah, 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 but I just got 3. Turns out that if both the numbers are integers, Python's division gives us an integer back. And this is actually true for a large number of programming languages. If you do division with 2 integers, you get an integer back, which is the quotient in the old elementary school quotient and remainder version of division, which you learned a very, very long time ago. The thing that's weird there is 4 divided by 13 is 0. Because 4 divided by 13 is 0, remainder 4. 13 goes into 4 0 times because it doesn't go in at all, and it leaves us with a remainder of 4. That's what's happening here. Target is smaller than source in this example. Target was 200 in both cases, and source is like 800 by 600, I think. And so both of these end up being 0. So the width scale was 0 and the height scale was 0. So these were X target and Y target were always 0, regardless of X source and Y source. So we were always copying into the upper left-hand corner. Oops, that doesn't seem good. So, and that's why we ended up with white, because we never copied into any of the other pixels. There probably was one colored pixel up there at the very top if we had blown it up to look at it. But everything else was going to be white. So, oh, that's sad. We have to deal with that. And this could come up in your collage. So this is good that we just sort of ran into this little issue. So what are we going to do? Well, the simple thing to do, strangely enough, is to multiply by 1. But not any 1, 1.01, right? Because then that turns that into a floating point division, and we get a proper floating point answer. So that forces it to be a floating point computation, and it will go ahead and give us a floating point answer. So that should make this better. So let's try that. Questions about that? That was actually kind of weird and complicated, so definitely ask. There's some discussion of this in the book, but we haven't talked about it in class anywhere. So let's do small gate again. Ooh, we got a problem, Houston. So first arg can't be coerced to an int. So the problem here is now get pixel wants an integer here and here, but these are no longer integers because this is some floating point thing and height scale is some floating point thing. So we actually have to convert back from floating points to integers after we do the multiplication. So we have to do the multiplication as float, then convert back to integers, and we can use the int function to do that. One more time. Oh, and actually I should show you int. Let's say if we have, so if we have 600, so let's say this is our scaling factor is 0.75, and we have pixel 127 times 0.75, we get 95.25. If we int that, it'll just round down to 95. And so we'll be using location 95 instead of location 95 and a quarter, because we can't do 95 and a quarter. Okay, so load, rescale, show small gate. Hey, that worked. I can't actually move this because, oh, I can now. Okay, whoops, zipper didn't work. There we go. So that made it 200 by 200. Notice it squashed it some this way horizontally and stretched it out a little bit vertically. So the gate's a little sort of taller and thinner than it was in the original image. And that's because we went from, I think, 800 by 600 or something like that to, well, I guess we could ask Jess. Get width, gate, get height, gate. So actually it was 800 by 533. And which is an even stronger ratio. And when we squarified it, it got kind of squidgy. Okay. And we could squidgy it in other ways. So we could say warped gate scale to, oh, I don't know, let's say 800 tall. No, the first one's the width, right? Make sure I'm doing this right. Yeah, the first one's width. So let's say we want it to be 400 wide and 800 tall. Show warped gate. Okay, so now it's more stretched. There's sort of an odd effect going on. What is that weird effect? Why is it faded? Because we didn't do any fading. We never changed the colors. Anybody?
Like some pixels are not colored.
Why would that be, Yubo?
Because the pixel is getting bigger.
Not quite, but you're close. So if we explore this just to have a look, we can confirm that Yubo's right. And let's see, if we zoom to like 200%, 500%, notice that we get like rows of white interspersed with rows of color. Okay. And this is because, anybody? Why did it happen vertically and not horizontally? Why did we get this weird thing? Every other row was white, but we didn't get something like that in column. It's because we're making the picture. Actually, I should have probably stuck in Explorer. We're making we're expanding the picture to be higher than it was initially. The initial height was only 533, and we're making it 800 tall. And so we're leaving gaps. The algorithm that I have leaves gaps when it does the multiplication and stretches the pixels out. Whereas we're taking it from 800 wide to only 200 wide. And so there, we're not having to fill in any holes, we're actually squishing it down. But here, we're not filling in the hole because I took my loop goes over every pixel in the picture, not in the canvas. So I'm not ensuring that every pixel in the canvas is getting a color. I'm ensuring that every pixel in the initial picture goes somewhere, but I'm not checking that everything in the canvas gets something. And so if I make it smaller, this will work great. If I make it bigger, I'm going to have gaps that need to be filled in. And so you would have to do this slightly differently if you knew you were going to have to, if you knew you were going to be making things bigger. And so, you know, in our case, if you know the picture's at least 200 by 200 and you scale it down to 200 by 200, then you know you don't have to worry about this. If you were to take the 100 by 100 and scale it up to 400 by 400, you'd have to use the doubling thing that we talked about earlier, or the, actually in that case, quadrupling thing, to make sure you didn't leave a bunch of white space in it. And the visual effect of the white space is, as was pointed out, that it looks like it sort of faded the picture. And when you get up close, it actually, you can see the stripiness, but from a distance, it really just looks like it faded the picture, because we're basically, half the pixels are white now. So visually, we've lowered the color intensity by half everywhere, okay? Okay, questions about that? I'm not going to try to fix that. We've got 4 minutes. I want to try to actually finish the thing where I put it in another picture. So if I do my copy onto here, copy onto, and my copy onto takes background, inset, X offset, Y offset, for pixel and get pixels inset, X equals, or let's say source, X source equals get X pixel, Y source equals get Y pixel, color equals get color pixel, X target equals X source plus X offset, Y target equals Y source plus Y offset, get target pixel equals get pixel X target, Y target, set color target pixel. Oh, get pixel needs to have an image. I constantly forget that. That's background. Set target pixel to have color. And that should, I think, put that in there. I did that super fast, so definitely shout, scream, and holler if you're like, what in the world? Grab the gate picture, grab dog stool. And then I want to call my montage. And I'm going to use dog stool as the background and gate as the inset. Show collage. Boom. There we go. So the gate's been shrunk to be 200 by 200 and has been placed up in the top left-hand corner. Questions? in the 1 minute that remain? Did that help a little? Any other questions quick? So you've got collages to make. We will obviously not start sounds today because we don't have time. I will start sounds on Wednesday. So I would definitely read chapter 7. There's a lot at the beginning of chapter 7 that's like background on sound and acoustics and stuff like that. All of which is interesting, but much of which is not really directly necessary to be able to like write programs that manipulate sounds. So feel free to kind of skim the beginning, depending on your level of interest, until you actually get to Jest code and then sort of wake up some more. Some of it is important, and we will go over some of that on Wednesday, but don't let the beginning of chapter 7 sort of overwhelm you and get you, bogged down, because there's a lot of information there, and we don't necessarily need all of it to be able to do what we want to do. So, coolio? Okay, go Team Ra. We'll see everybody later. Ciao. No problem.